In this video, we're going to talk about logarithms and exponents, and the SAT exam is replete with both exponents and logarithms. So it will behoove you to really become an expert on how to handle these. The first thing you need to do is to be able to convert from this logarithmic expression to an exponential expression. So the first thing you should do is put an x here, because after all, you're trying to evaluate this. The next thing you do is what I call the whirlybird method, where you take the base, you raise it to the power of x, and you set it equal to the argument. So you now have 2 to the x equals 8. Whenever you see 2's, whenever you see 8, 16, you know that the base of 2 is going to be intimately involved with solving this equation. So we are going to convert 8 to 2 to the third. Now we have 2 to the x equals 2 to the third, and at this point, folks, you pattern match. You say to yourself, okay, there's an equal sign here. That means this expression on the left has to equal this on the right. The bases are the same, therefore the exponents must be the same. So the answer to that is x equals 3. Let's do another one of these. Here we have log base 3 of 9 equals. Again, put your x in there, do the whirlybird. You're going to have 3 to the x equals 9. This one you'd be able to do intuitively, but the concept is to get the common base. It's not always this obvious. Once the base is common, the exponents must be equal. Therefore, this is going to be 2. You also need to be able to convert an expression that's in exponent form to logarithmic form. So here you say to yourself, okay, if this is now an exponent form, if I'm going to convert this to logarithmic form, I know that the word log has to be written down. So that's the first thing I do. The second thing I do is I say, okay, this is the base of the exponential equation. The yellow arrow is the base, and the blue arrow here is the exponent. So in my logarithmic form, I make the base of the log the same as the base in the exponential equation. Then I put an equal sign, and then I envision doing whirlybird. When you do whirlybird, you know that the base is going to be raised to the exponent right here. So x must go here. So now we've written the word log, we've written the base. We take a brief look at this equation and see that 5 has to be raised to x, which means x is on that side of the equal sign. Well, folks, the only thing left is the 25. So that's how you convert from this exponential form to this logarithmic form. Let's try another one of those. Here we have an exponential form. Let's convert that to logarithmic. First thing I do is I write the word log. We know it has to be there. Second thing, I write the base. Next, I take a look and I see that the base has been raised to 3. That means 3 must be on the opposite side of that equal sign, because that's what we do when we do whirlybird. The only thing that's left is 64. So there's your answer. The other thing you need to be able to do is expand and condense logarithms. If you have this expression shown here, there is a property of logarithms that you can expand this. Let's look at that. Okay. Here we have, this is the one we're looking at. So you have log to the base b of m over n. So in our example, we have log to the base 10, because there's an understood 10 here, with this fraction. So notice the numerator m is going to have a positive sign in front of it, and the denominator here, n, is going to have a negative sign. So we're going to do the same thing. We are going to expand this out, and we're going to have the log of r squared plus log of s to the fifth minus log z to the sixth power. All of those are base 10. So we expanded this form to that form. Now, there's another property of logs, we might as well get into it right now, whereby if you have an exponent of the argument, you can bring that out front. So this now simplifies to 2 log r plus 5 log of s minus 6 log of z. That was number 3 shown here. So here we took this n, like November, and brought it out front, and that's exactly what we did during the final simplification of that last problem. We just did an example of an expansion. Now let's go ahead and condense an expression. Okay, the first thing we're going to do is we are going to use the exponent rule and bring these exponents up top. That's going to give us log of x squared plus log y cubed minus log z to the fourth. We are going to condense these to one logarithm, so we're only going to write the word log once. We're going to have a fraction here because we have a minus sign. If they were all plus signs, we wouldn't need that fraction line. There's a plus in front of this one. That means the x squared, this argument goes in the numerator. This argument's going to go in the numerator because it's associated with a plus sign. This argument is going to go in the denominator. And that is our final answer. The next thing I want to review is what's called the change of base formula. And the change of base formula is a very powerful weapon in solving logarithms. So if you're confronted with this and you want to set that to x and you do early bird, you're going to get 4 to the x equals 5. And you're going to hit a stone wall here. You cannot convert 5 and 4 into the same bases and try to match the exponents like we did in one of our initial problems. So here you utilize what's called the change of base formula. And another way to think of the change of base formula is you are making things calculator friendly. That's what this technique is about. Now, if you look on your calculator, folks, you won't find a log to the base 4 button. The only log buttons you'll have is log and ln. Log is understood to have a base 10, and ln has a base e. So the goal here is to get this equation into one of these two forms, and therefore you're allowed to use your calculator. That's the game plan here. Okay, so how do we do that? Well, we utilize this rule right here. Here it is, the change of base formula. So here's your original log, in our case. B, the base is 4, and the argument is 5. And then you just put the log of x on top and the log of the base below. Now notice, the new base is d. You can pick anything you want. So let me show you how that's done. The first thing we do is we don't pick a base right away. So we call this log of 5 over log of 4. This base here can be anything we want. And as you'll see in a subsequent problem, we don't always choose 10 or base e to make it calculator friendly. Sometimes we choose a base that makes it more efficient to solve a problem. But in this case, we are going to use log base 10 because that is calculator friendly. So what you do, folks, is you just press 5, then the log button, and if you were to do that, you would get 0.699. You do the same thing with the denominator, 4 log button, and you would get 0.602. And when you divide them using the calculator, you would get a final answer of 1.16. Okay, for our last problem, we're going to use a combination of techniques that we've just learned. So let's look at this problem here. We have log to the base 4 of x plus log base 16 of x plus log base 2 of x equals 7. Now, folks, we are not allowed to condense this. Why? Because the bases are different. You can only do the condensing if the base is the same. If you look back here, when we're expanding and condensing here, the B means that that base is the same. Any of these maneuvers mandate the same base. We don't have that here. All right, so what might we do here? Well, we are going to use the change of base formula. So we're going to take each of these and use the change of base formula. We're not going to pick our base yet. Okay, now which base are we going to pick here? Here, 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 and here. Well, I gave you a hint when I left that last term alone. We're going to choose base 2. And the reason is, if we choose base 2, we'll be able to evaluate the denominators of the first two terms. Okay, here's what I mean. We're going to take this expression right here and do a little miniature evaluation of that. So we're going to have log to the base 2 of 4 equals x. We're going to do whirlybird, and we're going to say 2 to the x equals 4. 4 is 2 squared, therefore x equals 2. So I'm going to take x equals 2, and I'm going to substitute it in for there. Okay. I'm going to do the same little miniature equation for the denominator of the next term. Okay, let's do this in a different color. I'm going to do a little miniature equation here. So log to the base 2 of 16 equals x. 2 to the x equals 16. X equals 4. So now I'm going to take this and substitute it where you see there. Okay, so let's make this a little neater. Let's erase this and replace this with 2. And let's erase this. Replace that with 4. And let's reassess what we have here. Okay, now we have log base 2 to the x everywhere. Okay. This is 1/2 log base 2 to the x. This is 1/4 log base 2 to the x. And this is 1 times log base 2 of x. We can replace this with 2/4 plus 1/4 plus 4/4, and we have 7/4 log base 2 to the x equals 7. Okay, now let's take this, and I'm going to show you how to simplify that last expression. Using some of the principles that we have covered thus far. I'm going to take this coefficient that's out front and I'm going to bring it back and use it as an exponent for the argument. Now we're in the familiar position of using Whirlybird. So we're going to have 2 to the 7th equals the argument, 7/4. Now, in any equation, in any problem that we do in math, our goal is to try to get x by itself. Our goal is to try to solve for x. When we solve for x, that means we have x to the first power equals something. How would we get this to equal x to the first power? Well, the answer would be to raise that side of the equation to the reciprocal of what you see there. So what we're going to do is we're going to raise this to the 4/7. Then we're going to apply the power rule, and we're going to end up with x to the first power. Of course, we have to do the same exact thing to this side. And when we multiply 7 times 4/7, the 7's cancel out, and we get 2 to the 4th. And folks, that is the final answer. 2 to the 4th equals 16.